Here we are on chapter 8, and we're going to start with problem 810, dealing with the number of pizzas consumed by university students. It says it's normally distributed with a mean of 10 and a standard deviation of 3. And so the question for part A is, what portion of the students consume more than 12 pizzas per month? So we need to convert that to a z-score. So we've got our formula z equals x minus mu divided by sigma, or the standard deviation there. And if I scroll over here a little bit, you can see I've got that laid out. So the probability of being greater than 12 is 12 minus 10 divided by 3. So I'm just going to do that calculation right here. So it's equal to 12 minus 10, and I should have that in parentheses. Oops, sorry about that. 12 minus 10 divided by 3, so it's basically 2 divided by 3, which is going to give us the 0.66667, and I'm just going to simplify that by going down to 2 decimal points there, 0.67. And then we can go ahead and find the idea would be it's going to be, maybe I'll move this over. It should have been, well, no, fine, we'll leave it there. It's P for Z greater than 0.67 is equal to. And so now we can use the tables. So we're going to go to table 3 again to start with, and that's on page 310 for, and in this case, when we look at that table on 310, we're going to go to the 0.6 on the Z column. So 0.6, and so that's on the row, and then for the column it's going to be 0.07. 0.07. So when we do that, we go first on the row to 0.6, and then we go over to 0.07, and we get 0.7486. 0.7486. Now the other way that we could do this, but again I want you to show your work so that I make sure you understand, in case you get something wrong, that I can give you partial credit. And I should put the arrow up here, over here, to show you that it's 0.67, which is somewhere about here. So what we're looking at is calculating the likelihood that it's in this area greater than 0.67. So again, when I do this calculation, equal norm, and it's going to be the z-score, which is 0.67, and we're going to put in a comma there, and true for the cumulative, hit enter, and again, if we back that down to the same number of decimals as the table, we get 0.7486, and in this case what we're really looking for in that probability is 1 minus the probability of Z less than the 0.67 equals So it's going to be equal to 1 minus, and you can click on either one of those to give you the answer of 0.2514. So that's the probability in this case that the students consume more than 12 pizzas per month. Now the second part is a little more tricky. What's the probability in a random sample of 25 students more than 275 pizzas are consumed? So what we first need to do is just calculate this in terms of the mean. So here I've got it set up. The 275 divided by the 25. Now, just so you know what that is, I'll do that right here. 275 divided by 25, which is actually 11, if you can do that well in your head. So in this case, and I put X bar here for the sample mean, and I just set it X bar because it's easier than putting the bar over in terms of the notation here in Excel. But again, I'll go P, I go X bar, and it's greater than 11 is equal to, and again, let me scroll over here, and I've got this formula written out. So you've got the probability of X bar, which is the sample mean minus the population mean, divided by the standard deviation divided by the square root of n. So that's where we get all of this, and just to show you that calculation, in this case I'm just going to go, and I'll show you an easier way in problem 12, but it's equal to 11 minus 10 divided by 3 divided by the square, oops, the square root of 25. And when we do that, it's 1.67. So to figure that out, again, we would go to page 310, and I'll post this file so you can view the file as you're watching the video. For 1.6 on the row and 0.07 on the column. So again, we'll go to page 310, that's table 3. And we go down to 1.6 and then across to 0.7, and you see that at 1.600 it's 0.9452, but we go over to 0.07, it's 9525, so it's 0.9525, and again I can verify that using the normal distribution function right here. So it's 1.67. We'll do it cumulatively. Oh wait, I typed the period instead of the comma. Again, for those parameters, the comma is what separates them. And then hit that. And again, it displays more decimal places than we need. So just so you see that it together, I go up here and show only the first 4 digits to the right, and you can see that matches. And now what we're looking at here is the probability of 1 minus probability of z being less than 1.67 is equal to, and again, if we were looking over here, we would move this to reflect that. So instead of 67, we'd move it 1 to the right, so it's like 1.67. So it's 2/3 of the way from 1 towards 2. And again, it would be equal to 1 minus 0.9525, which is equal to 0.0475. So the probability of a random sample of 25 students consuming more than 275 pizzas is 0.0475. That will be it for now. I'll come back and do problem 8.12.